Hi, so we'll be going over question 8, cyclic generator. So here we are implementing the generator function, which takes in a non-empty list of one argument function, and non-empty list values, and applies the function to the elements of values in a cyclic fashion infinitely. Note that the length of functions might not be the same as the length of values. So looking at a doc test for an example, here we have a list of functions, we get a list of values, we create our generator, and then we call to get our first generated value of applying our first value to our first function. So here we're gonna get our first function is just the value, so we're gonna get 2. We move on to our set, we go next function, next value, F3 F2, applying 3 to F2. So we get 3 plus 1 equals 4. And then we call next once more. We do 4, F3, so 10 minus 4 equals 6. And so on, we keep cycling through. We've hit the end of both lists, so then we go back to the beginning of F1 and 2, hence why we get 2 again right here. And as we can see, this works if our values and function lists are different sizes. So here we have, first we go through each function. We've hit the end of our functions, we go back to our first function, and once again, like a cycle. For our values, we have more values, but still we go one by one, we call each one. So we have 4, so we do all 4, and then we go back to the beginning and do the first one again. So here, taking a look at the skeleton code, we have 2 variables, function index, values index, and then our while loop, which is where we will end up generating our values. So here I'll give you guys a second to look at the question and fill in the skeleton code, and then we'll go over it. We do get a hint, and it is to use the mod operator. So if you want to take a second and pause here, please feel free. Okay, so continuing on to part A, looking at blank A, we see that it is our conditional of our while loop. So this while loop is where we will generate our value when we call next, right? And we know that we want this to work forever. We never want this to end. We want the cycle to go infinitely. So because of that, we want to always be in our while loop. And the best way to do that is to just set our conditional equal to true. If our conditional is always true, we will never leave the while loop, and therefore we'll constantly be able to generate values indefinitely. Okay, moving on to blank B, we want to assign whatever we fill in blank B with to cur fn. So that basically implies we want cur fn to be a function, right? Because it's our current function for that iteration. So that means the way we know it's a function in our list of functions. So that tells us we'll be indexing into our list. And here we can also think to use one of our given variables, functions index. But let's make sure that we're always going to be having a valid index. And as the hint suggests, we can do this by using the mod operator. So how this is going to work is if we talk through mods themselves, they always give us the remainder of whatever number we're dividing by, right? So 0 mod 3 is going to give us 0. 1 mod 3, 1. 2 mod 3, 2. 3 mod 3, 3 divided by 3 is 0, it has a remainder of 0. So, and so on. 4 mod 3, 4 divided by 3 will have a remainder of 1. 5 divided by 3, remainder of 2. 6 divided by 3 doesn't have a remainder, and so on. As you can see here, it's we have a cycle. We go 0, 1, 2, 0, 1, 2, 0, 1, 2, 1, 2, etc. Anything mod 3 will always take on a value 0, 1, 2. And that's really helpful in this case, because as we can see in if we use our example function list, we have indices 0, 1, 2. So if we're indexing into our list, we want to index to 0, 1, 2. So we're gonna do, so here we want to do, so for this example here, we want to use, for this example right here, we want to use mod 3. That way we'll always get a value 0, 1, or 2. And if we want to generalize that, if you do like mod 4, the possible values are 0, 1, 2, 3, right? Because the remainder when you divide by 4 is either going to be 0, 1, 2, or 3, and so on. If you do mod 8, you're going to have either your possible values are 0, 1, 2, 3, 4, 5, 6, 7, right? And those are our possible indices when we have a list of a length 8. So with a list of length 3, our possible values are 0, 1, 2. So therefore, if we mod by the length of our list, we'll always get a valid index. Okay, moving on to blank C, current value. So pretty similar to current function, we want this to be a value from our values list. So we know we're indexing into our values, and using the same logic as part B, can use our values index. So we know where in our list we want to be to make sure it's a valid indice. I'm going to do length values. And here we can also see that that we can have a mismatch of length values to length functions, right? Like here, because we'll get the correct call. Blank D right here. Okay, so let's look at this line. Cur function, current value. So we know our current function is going to evaluate one of the functions in our list. Our current value is going to give us a value in our list, and function called on our value is a value. And this value is actually going to be the value we want to generate when we call next, right? Like if we just pick an arbitrary next call, this is the same thing as this, right? So this is what we're actually generating, our final value. So the way we do that is actually with yield, because we're doing a generator, right? So we never want to return anything, we're just yielding it so we can continue on for the next cycle when we call next again. Okay, on to blank E, you can see that it is the same for the last two lines. And here, we can see that we're doing a cycle, right? We're iterating, we're going up by 1 each time. So our index is going up by 1, because when we have our two lists, we want to go first value to the second value and so on, right? So we're just going up by 1. So there we have blank E.